The James Webb Space Telescope has revealed a true cosmic monster behind the unassuming name LID 568. Lies the largest black hole ever discovered, a giant whose mass and growth defy all previous notions. It devours matter at such a staggering speed that even experienced researchers are amazed by this discovery. How could such a massive black hole form in the early stages of the universe? Its sheer size and rapid growth once again contradict all current theories of astronomy. LID 568 could reveal other previously unknown mechanisms, and this black hole could be the key to a completely new cosmic reality. It is discoveries like LID 568 that shake our understanding of the universe. The James Webb Space Telescope has detected a black hole that surpasses anything researchers have ever expected. LID 568 is its sober catalog name, and what sounds so harmless is a supermassive black hole that existed just a few 100 million years after the Big Bang. We're talking about a time when, according to previous theories, it was hardly possible for such a giant object to have formed at all. But it's not just the early existence of this cosmic monster that is surprising. The speed at which LID 568 devours matter is also 40 times greater than what astronomers thought possible. It's growing at a rate that not only overturns all models of black hole evolution, but also raises a question of how black holes formed in the early universe in the first place. Researchers are calling it a cosmic baby giant that is so voracious that it challenges our entire understanding of the early universe and galaxy formation. LID 568 is by no means an isolated case. Scientists suspect that there are many more of these hidden giants in the depths of space. LID 568 was discovered while observing a particularly ancient galaxy field. And once again, the jwst delivered spectacular infrared data that allows us to see deeper and clearer into the early universe than ever before. The latest revolutionary discovery could be crucial to our understanding of cosmic evolution. The evidence that black holes play a key role in evolution is magically coming together. What role do black holes really play? Can you imagine that black holes were the logical consequence of some mathematical formulas? It sounds crazy, but it's true. Albert Einstein and a German physicist named Karl Schwarzschild came to the conclusion almost simultaneously that there must be collapsed objects with infinite mass in the universe. That was around 1916, and for a long time, these objects haunted science as phantoms. At an astronomy conference in 1967, the existence of these objects was hotly debated again, and the term black hole was coined shortly thereafter. In 1972, the first real black hole was discovered by a radio telescope. More than 40 years later, a black hole was captured on camera for the first time. The tricky thing about these monsters is that they are not actually black but invisible. They only become visible through the disks of hot, glowing matter around their event horizon. Today, we know of 3 types of black holes, rather small ones that remain after the end of a star, medium-sized black holes that were probably created by the fusion of smaller ones, and the supermassive giants that occur at the center of galaxies. The fact that supermassive black holes can be found at the center of billion-year-old galaxies is not that unusual, but what is strange is that they appear in images of the early universe. Some of these giants, existing only a few 100 million years after the Big Bang, are up to several billion times heavier than our Sun. How is it possible that these black holes grew so rapidly when there was hardly any matter available? Once again, we have to push the boundaries of our imagination. What if black holes were already there at the beginning of the universe, or even span cycles of universes? These dark giants may play a central role in the development of the overall cosmic structure and are key elements in our quest to understand the universe. The problem, however, is that our means of exploring black holes are very limited to this day. Researchers have almost exclusively relied on mathematical concepts, such as those developed by Albert Einstein and his colleague Karl Schwarzschild. What really goes on inside these giants could be a surprise. For a long time, black holes were considered pure destroyers, mysterious objects that devour everything that comes near them, even light. But the deeper astronomers peer into the cosmos with modern telescopes such as the jwst, the clearer it becomes that these dark giants may play a much more constructive role in the universe than we previously thought. Supermassive black holes form the center of almost every large galaxy. The big question is, which came first, the galaxy or the black hole? One idea goes something like this. A giant star in the early universe exploded, leaving behind a large black hole. This black hole attracted other stars in the vicinity, and as they also exploded or were swallowed by the black hole, the hole continued to grow. In this way, More and more stars were attracted, which was possible due to the weight of the black hole alone. A group of stars formed around the center, and a galaxy was born. New research therefore suggests that black holes do not simply arise because galaxies grow, but that they actively participate in their formation. The only strange thing is that black holes with astonishing masses already existed in the young universe, only a few 100 million years after the Big Bang. These early giants are actually much too large to have formed purely from a matter in their environment in such a short time. Black holes may not only be the secret architect of the universe, they also shape their environment in complex ways through so-called jets, high-energy matter ejections, and the release of enormous amounts of radiation during the accretion of gas. They can regulate star formation, in some cases stimulating it, in others suppressing it. They act like a cosmic thermostat, sometimes driving, sometimes slowing down. The extent to which these processes contribute to the structuring of the galaxy is still unclear. The dynamics could possibly explain why young galaxies already exhibit an unusually high degree of order. The large-scale structure of the universe, known as the cosmic web, could also interact with black holes. There are indications that they help stabilize filaments of matter that connect galaxies like strings of pearls. All these new findings force us to completely rethink the role of black holes and see them not just as mere endpoints of matter, but as active shapers of the cosmic order. What was once considered a deadly singularity could turn out to be one of the most creative builders of the universe. How the James Webb Telescope makes black holes visible. Black holes are among the most fascinating and mysterious objects in the universe. They are regions within space-time where gravity is so strong that nothing can escape. This is precisely what makes these phenomena so elusive. They emit no light and leave no measurable trace in space. Instead, they reveal themselves only through their enormous gravitational pull and the mass they accumulate around them. Identifying them is particularly difficult in the early universe, where these giants appear to play a much greater role than previously thought. Black holes can lie hidden deep within young, dense, dusty galaxies, and their light is shifted into the infrared by the expansion of the universe. This is where James Webb comes into play again. With its 6.5-meter mirror and highly sensitive NRCam, Webb is specially designed to capture the first light of the universe. The jwst is unique in its ability to see through cosmic dust. While optical telescopes such as Hubble are slowed down by dust clouds, Webb effortlessly penetrates these barriers and makes the previously invisible visible. Webb also uses instruments such as the NIR-SPEC spectrograph to analyze spectral lines from rotating gas masses in the center of distant galaxies. When these gases move at enormous speeds, it's a strong indication of a supermassive black hole. This enables the jwst to detect completely new, previously invisible black holes, fundamentally changing our understanding of the young universe. The 6 impossible black holes that Webb discovered in its first few months of operation have already gone down in the history of astronomy. Since then, there has been a flurry of discoveries and speculation about their mysterious significance. All of the telescope's discoveries seem like a puzzle that is gradually coming together to form a new picture, and black holes could be both the great unknown and the solution to the puzzle in this game. jwst accidentally discovers giant black hole GNZ7. Important astronomical discoveries are often the result of pure chance. This is also true of the discovery of GNZ7, a black hole that is not something you see every day in the cosmos. Researchers first noticed indications of an unusually large spot in data from the Webb telescope whose light was strongly shifted toward the red. Only slowly did it become apparent that this spot was a gigantic quasar, GNZ7, already existing when the universe was only 750 million years old, within a galaxy that probably produced an unusually large number of stars. Researchers now consider this important discovery to be the missing link between possible early starburst galaxies and the development of supermassive black holes in the young universe. Existing theories assume that supermassive black holes originate in the core of starburst galaxies where there is more matter. Black holes can also develop more quickly into bright quasars. Supermassive black holes have 1 million to 1 billion times the mass of the Sun and play an essential role in the center of galaxies. One example of this is Sagittarius, the supermassive black hole at the center of our Milky Way. Quasars are the extremely bright centers of active galaxies, and their high luminosity is caused by the large amount of matter they accumulate and slowly devour in their surroundings. The glow emanates from the accretion disk surrounding the center of quasars. It's also possible that a glow is produced by a dust shell surrounding the center. In this case, the black hole itself is also invisible. The connection between starburst galaxies, the rapid growth of black holes, and the formation of matter in the early universe is currently one of the greatest mysteries of astrophysics. All of these phenomena do not quite fit into the framework of old theories. It's possible that the first stars did not appear slowly in space but shot out explosively from the primordial soup of the cosmos. Behind this possible development could lie a previously unknown driving force, and black holes could have been the great stabilizers in this cosmic symphony. Click subscribe now and be there for every new video.